Hi, I'm Professor Kelly, and this is a lecture on Parse Trees for CSCI 308, Programming Language Design. The learning goals for this lecture are to be able to draw a parse tree for statements, expressions, and programs, and to define and identify ambiguous grammars. The building blocks of a compiler, or interpreter, or programming language are statements and expressions. In declarative languages, we only have expressions, but in imperative languages, we have both statements and expressions. Statements have side effects, and expressions have return values. We can define what variables and numbers are legal in the language using regular expressions, but how do we define statements and expressions? Expressions are defined recursively using BNF rules. An expression is a number, a variable, or any combination of expressions using operators and functions. Let's construct a parse tree for 3 plus 4 plus 5 using the grammar shown on the left. To construct a parse tree, we start with the start symbol. In this case, let's use expression as the start symbol. To create the next level of the tree, we apply part of the expression rule. Here we are applying the first part, replacing expression with expression plus expression. Let's keep adding to the tree by applying more rules. We can replace the left expression with num, and the right expression with another expression plus expression, and then each of those expressions with num. Now we have the parse tree for 3 plus 4 plus 5. Note how 3 plus 4 plus 5 is being implemented here. We are first adding 4 and 5 to get 9, and then we're adding 3 and 9 to get 12. This isn't the only possible parse tree for 3 plus 4 plus 5. We could just as easily have done this. First adding 3 and 4 to get 7, and then adding 7 and 5 to get 12. This is what's called an ambiguous grammar. An ambiguous grammar is when there are multiple possible parse trees for the same sequence of symbols. In the case of 3 plus 4 plus 5, having an ambiguous parse tree is just fine. We get 12, the desired result either way. But what happens when we use minus? 3 minus 4 minus 5. If we do 3 minus 4 first, we get negative 1, and then negative 1 minus 5 is negative 6. Conversely, if we do 4 minus 5 first, we get negative 1, and then 3 minus negative 1 is 4. We get a different result. Ambiguity is sometimes a problem. Let's consider a grammar that combines statements and expressions. Our first rule has to do with statement lists. A statement list is something that allows us to have at least one statement, but it can also allow us to have more than one statement. We can replace statement list with statement and statement list. This allows us to generate as many statement lists as we need. A statement can be an if statement, or it can be a while loop, or it can be an assignment statement. In real language, it could also be a for loop, or any number of other things. An if statement is if followed by an expression and then a statement list. The statement list here is all the statements inside of the if. An assignment statement is a variable followed by an equal sign and an expression. Again, this isn't a real language. This is just some pseudocode. Expression can be an expression less than an expression, or it can be an expression plus an expression, or any number of other operators. Or it can be a number and a variable. Suppose we wanted to create a parse tree for if x is less than 3, x equals y, y equals 5. This is a pretty simple piece of code, but despite its simplicity, the parse tree for it is actually quite complex. To start off, let's use statement list as our start symbol. We can replace statement list with statement. We don't actually need more than one statement. There's only one statement outside of the if condition, and that is the if statement itself. We replace statement with the if statement, and that becomes if expression and then statement list. the statement list being the statements inside of the if. We can replace the expression with expression less than expression, and replace each of those expressions with var x and num3. Now let's tackle this statement list inside of the if. We want two statements, so we're going to apply the second part of the statement list rule. This gives us a statement and a statement list. We can then apply statement list again to replace the statement list with just a statement. We only need the two statements. The statements are both assignments. Let's apply statement can be replaced with assignment statement to the first. X is the variable, and we have an expression that x is equal to. We can replace the expression with variable, which is y, and then we can do the same thing for the other statement, replacing it with an assignment statement. And there we have the complete parse tree. So where does statement list come from? We were using it as our start symbol in the previous one, but how do we create a program? Do we start with statement list? Well, imperative languages are just lists of statements. Conversely, a declarative language only has expressions. Let's say we use program as the start symbol for a program. We could have an imperative language that just allows you to replace the start symbol program with statement list. Some imperative languages may be a little bit more fussy. They may require you to have import statements first or a set of declarations first. Let's take a look at Java. If you want to know the BNF for a particular language, you can just Google language name and BNF and probably find the BNF rules. That's what I did here to find the Java BNF rules from this website. If we take a closer look, we can see the rule that starts off a Java program. Compilation unit can be replaced with package declaration, import declaration, and type declarations. So compilation unit is the start symbol, and then there's some number of package declarations, some number of import declarations, and some number of type declarations. If we look at the declaration rules, we can see that we can only have one package declaration, but as many import declarations as we want, and as many type declarations as we want. Type declarations is where the magic happens. Type declarations can be class declarations or interface declarations. Inside of a class, we can have blocks. A block is anything that is bracketed by curly braces. Inside of a block, we have block statements. Block statements plural is what Java calls statement lists. Block statements can be replaced with block statement singular or block statements plural and a block statement singular. A block statement, that's what Java just calls a statement, can be replaced with things such as variable declarations. So the learning goals for this lecture are to be able to draw parse trees for statements, expressions, and programs, and to define and identify ambiguous grammars. Parse trees are constructed with a start symbol at the root and the terminal symbols at the leaves. Each level of the tree replaces non-terminal symbols step by step using BNF rules. Ambiguous grammars have more than one possible parse tree for the same sequence of symbols. Expressions are constructed recursively from literals such as numbers, variables, operators, and other expressions. Statements are generated from a statement list and take various forms such as if statements, while statements, for statements, assignment statements, variable declarations, and so on. A program consists of an expression in declarative languages or of a list of statements in an imperative language. Some languages may require a program to start with a list of import or declaration statements.